Hello friends, myself Pushpender Singh, and we are going to start with our geography lecture. So as you know, the geography is one of the important subject in your preparation, specifically for the civil services examination. So geography along with the environment basically have the huge weightage not only in the civil services preliminary examination but also in the civil services mains examination. So it has huge weightage and it is also the current affairs oriented. So you have to study not only the static portion of your syllabus but also you need to focus on the current affairs portion of your geography. All right, so I'm the faculty here, so you would be learning more about the geography and the environment as we proceed along the course. All right, in the today's lecture we are going to cover various topics like the shape of the earth. We are going to cover basically the latitudes, longitudes. We are also going to cover the motions of the earth. We have the rotation, revolution, etc. All right, so let's begin the lecture with the shape of the earth. So as you know that the common the perception about the earth is basically spherical in the nature, but earth is exactly not a spherical. It is basically an oblate spheroid. What does that mean? It does that simply mean that if you draw the structure of the earth, okay, you will have somewhat the bulge at the equator. Okay, so this is the equator, which is basically a 0-degree latitude. Okay, now if you draw this perpendicular line from north pole to the south pole, okay, south pole, you will find here you will have somewhat flattened surface. Okay, this is a bulge, this is a bulge, this is a flattened surface. So what does that mean? It does simply mean that the earth's surface is not a complete sphere. It is flattened at the polar areas, okay, or the poles, and it is basically bulge. It is basically in the equatorial region or in the equator. So what we call this length is basically your equatorial diameter. Okay, and what we call this as the polar diameter. Okay, so through that we came to know that the equatorial diameter is somewhat bigger than your polar diameter. It is because of the bulge. Why this bulge occur? It is because of the rotation of the earth on its axis. So primary reason is basically the rotation of the earth on its axis. So the spherical shape of the earth is basically because of some sort of a, you know, the gravitational attraction that we have. Okay, but there are also centrifugal force of the earth that the rotation has distorted the shape from the perfect sphere. That are also another reason for having some sort of a distorted shape. So what we call ultimately the oblate spheroid, which is a shape that we came to know. All right. Okay. Next slide. Let's see here how much it is bigger. How much it is bigger. So here the equatorial diameter is roughly 42 kilometers, you know, larger than your polar diameter. That means if you just subtract the polar diameter from the equatorial diameter, it would be around 42 kilometers. So because of that bulge, we have larger equatorial diameter than your polar diameter. Now, the next important point is that there is a relative lower value of the gravity at equator and the higher value at the poles. This is again a scientific, you know, explanation for that. For example, this is your earth. Okay, now as you know that this is a flattened, poles are flattened. Okay, now here at the equatorial region you have somewhat bulge. So what will happen? Your effective length of this diameter, equatorial diameter, would be larger, and your effective length of this polar diameter would be somewhat lesser. It is because of the flattened area. Okay, Now you might have studied in your school time the force of attraction. Let's say these are the two bodies, okay, having the mass of m1 and m2. They are located in the distance of, let's say, r. The force of attraction between the two bodies is, you can say, it's proportional to, or you can say it's inversely proportional to the square of the distance between these two bodies. Okay, this is a physical formula, or this is formula has been given through the physics. Okay, now as you know that this distance have increased, so ultimately this value would become larger. Once this value become larger, it will become lesser. It will become lesser. Similarly, this effective the polar diameter has basically reduced. So what will happen? This value has reduced. So this value have reduced. So ultimately square would give comparatively lesser value. If that denominator has the lesser value, you can say that the force of attraction would be larger. That is what the third point is saying, that the relative lower value of the gravity at the equator, and you have the relative higher value of the gravity at the polar region. All right. So I think this is clear. We shall move to the next slide. Okay. So here I have brought the bigger picture for you to understand how much it is bigger. Okay. So if you draw the picture of Earth, okay, if you draw the picture, and this is, let's say this is a smaller bulge area and this is a flattened area. Okay. Now if you just take a cross section of the Earth on this plane, if you cut the Earth, okay, in this plane also, what will happen? Let's say you are cutting the Earth's surface, or you are taking basically a cross section all along this plane. So what will happen? You will get, the Earth in this, shape, because this is a cross section. So what will happen? This, what we are talking about, a diameter, that is called basically your equatorial diameter. So ultimately in terms, it is 12,756. Once you cut vertically, we will get this type of, cross section of the Earth. And since it is flattened, so it will be somewhat lesser. So we are talking about this one, that is roughly around 12,714 kilometers, which is lesser than your equatorial diameter. All right. So you can say effectively the difference between two is around 42 kilometers. All right. Okay. This is what the similar representation, but it is in the miles. So you can easily convert the kilometers into the miles. All right. Okay. Now we will learn about these figures. So I just jotted down those figures specifically for you to note down. You can easily note down the polar circumference, equatorial diameter, then you have the polar diameter. These figures you can easily note it down from here. All right. Okay. Now we shall learn the most important topic of the geography, that is called the geographic grid system. So what is called geographic grid system? What is the need of deducing, or what is the need of evolving this geographic grid system? As you know that the globe that we see is some miniature form of Earth. Okay, we try to put everything on the globe as if it is located on the Earth's surface, but you know that the Earth's surface is very, very bigger. Okay, it's not very small, it's a very bigger. So it's very, very difficult for us to place every locational aspect, okay, on the globe itself. But we need to start from somewhere. So the scientists or the geographers have come out with the concept called grid system, okay, in which they have basically deduced some sort of a imaginary lines. We call them latitudes, or parallels of the latitude, as well as longitude. So we call them parallels of latitude and longitude. Okay. What is parallels of the latitude? See, the geographers again has taken basically a reference line, or the reference line which passes through the center of the earth. Okay, that makes the greatest circle, or that make a great circle. So it has basically, some sort of a imaginary line which passes, or which basically, divide the earth into the northern sphere as well as your southern hemisphere. So it divides the earth into northern hemisphere and the southern hemisphere. Now, with the help of the latitudes, okay, we will came to know that some horizontal lines have been drawn on the globe. Okay, some horizontal lines. These horizontal lines are basically, parallel to each other. So you must understand, they are nothing but circles. They are nothing but the circles that are lying all along the surface of the earth. But when you see the cross section of picture from the straight side, you would find that they are the horizontal line that runs through the surface of the earth. They are parallels to each other. Okay, the geographers have marked some of the standard parallels of the latitudes. For example, 0 degree. If I draw a diagram, 0 degree latitude, we call it as equator. Okay, similarly 23.5 degree north, that is called Tropic of Cancer. Okay, then you have 23.5 degree south, that is Tropic of Capricorn. Okay, then you have basically the Arctic Circle. Then you have the Antarctic Circle. Okay, and at the last you have basically your North Pole and you have your South Pole. So what you have drawn is basically an imaginary horizontal lines, okay, which never intersect each other, which never cut each other. They are parallel to each other. Okay, what we call them the parallels of the latitude. They are basically signified or denoted in degrees. So we will say that since equator divides the earth into two parts, so you can say that they are basically dividing the earth into the northern hemisphere as well as southern hemisphere. So we call them, the positions of this latitude along northern and southern direction. So you will say that the north, 23.5 degree north. Similarly, Arctic Circle, 66.5 degree north. Similarly, the North Pole, that is 90 degree north. When you come to the southern side, you will say that it is 23.5 degrees south. Then further down, 66.5 degrees south. Okay, because it's located in the southern hemisphere. And down you have basically 90 degrees south. Now again, we have drawn these lines. Again, still we need to draw one set of lines also, so that across sections or the intersections between the latitude and the longitude would give you the exact location of the place, So the again geographers again deduce another set of imaginary lines that we call basically, the meridians. Okay, that we call the meridians. Again, we need to have some of the standard meridian. So the geographers again chose the prime meridian which passes through the Greenwich, England. Okay, which is again computed at 0 degree longitude. So it is basically named at 0 degree longitude, which is called a prime meridian, which passes basically a Greenwich Royal Observatory in the UK. All right. Now, again, if I draw vertical line, that is prime meridian, that is 0 degree longitude, what does that prime meridian do? It basically again divides the earth into two parts, the eastern hemisphere as well as the western hemisphere, isn't it? So you say that again it divides the earth into two separate portions or two equal portions, but there are the difference between latitudes and the longitudes also. The latitudes, as I told you, they are the parallels of latitude. That means they are parallel to each other. Okay, when I say the longitudes are not parallel to each other. Okay, they never intersect each other first of all, okay? But they have a common point. They have a common point of origin, okay? Let's say this is the northern pole and this is a southern pole, okay? This is a prime meridian, that is 0 degree, okay? So they have basically some sort of a semicircles, so they originate from northern pole and ultimately, you know, merge at southern pole. Again, second set of semicircle, third set of semicircles, again this side, western side, okay, you have set of semicircles. Now what you are ultimately going to see here in this diagram, you have a semicircles. Again, you see here they are not parallel to each other because their distance keep on changing. At that position, you can say the distance is maximum. When you move from, you know, from the equator toward the poles, you know, the distance between two meridians keep on decreasing. So that is, they never intersect, but they have common origin and common ending. So they merge basically at the southern poles. Okay, they are called semicircles. Again, how would you find out the location of the particular area where the latitude and longitude cut each other, where they intersect each other? That point gives us the precise location of a particular area. So in this figure, you can easily see here, this is basically, you say 0 degree latitude, that is your equator, okay? 0 degree latitude. Again, in the northern side, you have 15 degree latitude, 30 degree latitude, 45 degree latitude. What you name it as basically 15 degree north, 30 degree north, 45 degree north, 60 degree north, 75 degree north, 90 degree north, because it divides the earth into northern hemisphere and southern hemisphere. Once you come down to the southern hemisphere, you would name them 15 degree south, 30 degree south. This way you will basically name them. Again, let's say this is your basically prime meridian, or this is 0 degree longitude. So again, I said that they originate in the northern pole and they basically merge in the southern pole. They originate northern pole, merge at southern pole, originate at northern pole, merge at southern pole. Similarly, in that direction, western direction also, this way. So what would you name that one? Let's say this is 10 degree. So you say 10 degree east. This is 20 degree east. Let's say 30 degree east. Let's say 40 degree east, because it divides the earth into eastern and western side. So you would measure basically, you know, towards eastern and western direction from the prime meridian. So you would say that meridians of the longitude. Okay. So that is again 10 degree, that is 10 degree, you know, west, 20 degree west, 30 degree west. This way you will basically, you know, name them. Okay, we shall move to the next slide so that you will have more clarity about the subject. Okay, again, what the geographers has done, they have basically, you know, the purpose was basically to find the precise location of a place. So what they have taken, the reference point for the location, that is basically your north pole and the south pole. That is the reference point they have taken. Okay. Okay. Now this is what I have drawn, the parallels of latitude. Okay, you see here, they are the parallels of the latitude. Okay. So what I have drawn here, the parallels of the latitude, this one, to find exact location of a place in this map. Okay. Again, you can see here, you have, since it is a grid, since it is a 2D picture, we have just drawn, you know, a 2D diagram here to depict what the exact location of that place. So you can find out the exact location. For example, we need to find the location of that place. So this, the longitude and latitude, where they cut, you can easily find out the location of the particular place here. All right, let's move to the next slide. Okay, this is what I have explained you. From North Pole to the South Pole, you have the parallels of the latitude. Okay, then you have basically your meridians. All right. This is again, I said that latitudes are basically imaginary lines that I have already explained you. They are the imaginary lines following true east-west direction. East-west direction, because they are parallels of latitude running through east to west direction. Okay, and ultimately dividing the earth. Okay, you can see here, if this is basically your equator or 0 degree latitude, again this is the northern portion and this is southern portion. So you can call 10 degree, 20 degree, 30 degree, 40 degree and 50 degree, that I have already explained you. Okay, let's move to the next slide. Okay, now as I told you that there are parallels of the latitude because they don't meet. The distance between the parallels of the latitudes always remains constant. Okay, and circles of the latitude, you can say, because they go round along the globe to form the full circle, that I have already explained you. They are basically circles. They go all around the earth as if they are the circles. Okay, now we have taken 0 degree as a reference, as the equator, which is located exactly at the halfway, where it forms basically a great circle. Another circles are not great circle. Why great circle? Because it's a largest circle that is formed at the equatorial plane. Others are basically a smaller circles when you compare to the equatorial circle. Okay, let's move to the next slide. Okay, this is what the latitudes, how would you measure, that I have already explained you. Okay, so you can say that latitudes are the number that has been numbered from 0 to 90 degree north and south, because when you take the distance from the center to the North Pole, it is 1/4 of 360 degree, because they are circle. So they are 1/4 of 360 degree, that is 90. So maximum you can go up to 90 degree north in the northern hemisphere, and maximum you can come down to the 90 degree south. That is how you would basically point them out. Okay, we shall move to the another important point that I have already explained you, the important latitudes. Okay, as you know that the earth axis is little bit tilted. It is tilted by around 23rd and half degree. Okay, from the vertical. So here this is the axis. Okay, or this is the rotational axis, where the angle is around 23 degree and half. It is the inclination of the rotational axis. The earth basically rotates along with this axis in the counterclockwise direction. All right, so we have made a imaginary lines. One is called equator, that is 0 degree. Second is Tropic of Cancer, that is 23rd and half degree north. Then Arctic Circle, 66 and half degree south. Then you have Tropic of Capricorn, 23 degree and half south. Then you have Antarctic Circle, 66 and half degree south. And you have South Pole, that is 90 degrees south. All right. Okay. Now this is just, I have already explained you, so there is nothing in that. I just made it for you to note down some of the important points through the lecture. Okay, this is what something we shall understand. This is the common terminology. When you say the lower latitudes means something which lies in the lower latitude zone, that is roughly from 0 to 30 degree north and south. When you say middle latitude, that means something or some space, geographical phenomena that lies within 30 to 60 degree north and south. When you say higher latitudes, that means beyond Arctic Circle or Antarctic Circle up to the basically North Pole and South Pole. Okay. Now, The next important terminology is basically your equatorial zone. So equatorial zone is nothing but the 5 degree north and 5 degree south. This zone we can call it as equatorial zone. The next is basically a tropical zone. You can call it as from Tropic of Cancer, that is 23rd and half, to the 23rd and south. So this zone you can call it as the tropical zone. You can call it as tropical zone. Subtropical, you can have around 25 to 30 degree north and south zone. Okay, we will learn about the pressure belts. Okay, you have the equatorial low, subtropical high, then you have subpolar low, then you have the polar high. Okay, we will learn about those belts in the little later when we proceed to the next level. All right, so we shall move further. Okay, so here what we calculate basically the northern and southern distance we can calculate, okay, in terms of degrees of latitude. Okay, that distance is around 111 kilometers. That is roughly a distance. So you can say that such distance can also be calculated in this regard. Okay, now this is longitude. I have already explained you, so there is nothing to explain in this figure. So I would say that simply they are basically again imaginary lines, runs from North Pole to the South Pole. They are semicircles definitely that runs from the pole to pole, okay, and they basically crosses all the longitude at 90 degree right angle. So that is something we can say that they basically calculate in terms of degrees to the east and the west of the prime meridian. Okay, again it can divide the earth into two equal parts. All right, next. Okay, again this is the similar depiction what I have explained you in the first slide. This is 0 degree longitude, that is the prime meridian. Okay, again you can say to the eastern side you have 10 degree east, 20 degree east, 30 degree east, 40 degrees. To the western side 10 degree west, 20 degree west, 30 degree west, and so on and so forth. Okay, again here you can say to the right side of the prime meridian you will have eastern side. Okay, to the left side of the prime meridian you have the western side. Simple to remember, no need to worry. Okay, this is what a bigger picture, so that you can basically feel how the longitudes are basically running from North Pole to the South Pole. Okay, all right. Okay, this is what I have explained you, the earth movements. See, there are two types of the movement the earth generally has. One is the earth rotates on its axis. As I told you that earth is basically inclined from the vertical plane by 23rd and half. So earth axis is somewhat tilted. Okay, so what we call the rotation is the movement of the earth, okay, along its axis. Okay, it is called the rotational or the rotation of earth. The earth completes its rotation in 24 hours, that you already know aware about it. Okay, second type of rotation is called revolution. Revolution is earth basically revolve around the sun. Sun is a star. Okay, revolve around the sun in a predetermined fixed path. We can call it as orbit. So you can say that the earth basically revolve around the sun in a fixed orbit. Okay, as you know that the earth takes around 365 days and 6 hours to complete one revolution, okay, around the sun. But we generally ignore the 6 hours in calculating 1 year. So 1 year roughly have 365 days. Okay, after every 4 years we basically add these 6 hours. Okay, in the 4 years that 6 hours basically become 24 hours, that is 1 day. So we can add all these 6 hours once in a 4 years to make a leap year. So in the leap year the February would be 29 days, and instead of 365 days you will have 366 days. Okay, so Earth basically moves, or Earth is basically have two types of motion. You have the rotation as well as you have basically revolution. Now the most important point is that there are different phenomena that happens because of the rotation. That is, you might have experienced the phenomena of day and night. The phenomena of day and night occur because of the rotational movement of the Earth. Has the Earth stopped rotating, you can assume what would have happened. Okay, a side which is towards the sun will have total light, which become hotter and hotter. The surface which is opposite to the side which is facing to the sun would become colder and colder. So it become, inhabitable place. Okay, so the rotation has very important aspect of the phenomena called day and night. Day and night. Okay, the next important phenomena you can say in terms of the seasons. You have different types of seasons. The seasons occur because of the revolution of the Earth all along basically your sun. Okay, all along the sun. So I have one slide, so we will explain the important aspect. Okay, we shall move further to that slide. Okay, let's move to this slide. So here what happens is that you have basically the movement of the Earth all along the sun. Okay, so you have basically four types of phenomena. One is called summer solstice. Okay, then you have basically winter solstice, then you have vernal equinox, and you have autumnal equinox. What is summer solstice? It is a phenomena when the sun is basically overhead at the Tropic of Cancer. That means the sun rays are directly falling on the Tropic of Cancer. Okay, so what will happen? The more amount of heat and energy would be received in the northern hemisphere. Okay, so what will happen in the summer solstice in the northern hemisphere? You will have basically summer. What would have happened in the southern hemisphere during summer solstice? Reversed or opposite. If it is summer in the northern hemisphere, in the summer solstice, there will be a winter in the southern hemisphere. Why? Because sun basically lying, at the Tropic of Cancer. So its energies, or its rays falling directly over Tropic of Cancer. So the rays which are falling on the Tropic of Capricorn, if I draw this diagram here, you would be better understanding. Let's say this is Earth, this is equator, 0 degree, this is Tropic of Cancer, and this is Tropic of Capricorn. So 23.5 degrees south, Tropic of Capricorn, 23.5 degree north, Tropic of Cancer, and let's say this is the apparent movement of sun. Okay, so sun move from basically Tropic of Cancer to Tropic of Capricorn. It never goes, or the apparent movement of the sun never beyond the Tropic of Cancer, never beyond the Tropic of Capricorn. So I'm talking about the summer solstice. Okay, the summer solstice on June 21st. Okay, what will happen? The sun is at overhead at Tropic of Cancer. Sun rays falling over Tropic of Cancer. So what will happen? The rays are slanting or oblique towards southern hemisphere. So it will have to cross so much distance. By that time, it loses its energy, it loses heat, and moreover, these rays are not falling vertically. So the per unit absorption of heat and energy would be somewhat lesser. Okay, so what will happen? There will be a summer in the northern hemisphere and there will be winter in the southern hemisphere. Okay, let's take another phenomena that is called winter solstice. The winter solstice happen on basically your December 21st. What will happen on December 21st? The sun is located at Tropic of Capricorn. That means the sun rays are falling directly over Tropic of Capricorn. So what will happen? The more amount of, or the more area in the southern hemisphere would be under light and energy. Same phenomena occur here. The rays, sun rays following not vertically over there, but rather, slantly. So per unit absorption of the energy would be somewhat lesser. So there will be summer in the southern hemisphere in the winter solstice, and there will be winter in the northern hemisphere in the winter solstice on basically December 21st. Is that clear? The two more concepts are there, that is called equinox. See, equinox happen because the sun the sun rays are following directly over the equator. So it is falling vertically over the equator. So you will have, basically, the same duration of days and night. So the day and night duration would be similar. There will not be any change. That means you will have 12 hours day, 12 hours night. That is phenomena that we call equinox. Okay? Same duration in terms of day and night. But what happens in terms of the summer solstice? In terms of summer solstice, in the northern hemisphere, there is summer, so the days are longer. So duration of the days are longer. But what about in the southern hemisphere? The nights are longer, because in the southern hemisphere you will have winter, so nights are longer and days are shorter. What about the winter, or in the winter solstice? Opposite happens, because sun rays are falling vertically on the Tropic of Capricorn. So what will happen when it is falling vertically on the Tropic of Capricorn? What will happen? You can assume that there would be summer in the southern hemisphere and there would be winter in the northern hemisphere. So if there is a summer in the southern hemisphere, what will happen? The days are longer and nights are shorter. If there is a winter in the northern hemisphere, what will happen? Nights are longer and days are shorter. But what about equinox? Equinox, you have the equal duration of day and night. One more thing you need to understand. There are two types of equinox. One is called vernal equinox. Second is called basically your autumnal equinox. Okay? Autumn, that is Sharad Ritu. Okay? That is called Sharad Ritu. Okay? And vernal equinox, when you have regeneration of those flowering plants. Okay? So in the northern hemisphere, always remember the vernal equinox or the spring equinox would occur in the month of March, but autumnal equinox would occur in the month of September. So that is clearly mentioned here. In the basically March 20th, you will have vernal equinox. Okay? Then in the September month, you will have basically another set of equinox, that is called autumnal equinox. Okay? But what happens in the southern hemisphere? In the southern hemisphere, it is again reversed. You will have vernal equinox in the September and autumnal equinox in the month of March. Okay? Now you can feel this by this diagram. Okay? If I go back to this diagram, okay, you can visualize this diagram. See here, this is called circle of illumination. That is called circle of illumination. That is, the half portion of the earth would receive the light. Half portion would be in the dark. So that basically divides the darker and the lighter space is called the circle of illumination. So again, this is the sun. Sun rays are falling on the surface of the earth. Now I said it is tilted. It is tilted. Okay? So more area of the northern hemisphere would get heat and energy if the sun lies at Tropic of Cancer. Sun lies at the Tropic of Cancer. So the area which lies beyond Arctic Circle would be having continuous 6 months of daylight. Okay. Similarly, if it is basically at Tropic of Capricorn here, you can understand, you know, the rays which are following here are slantly, and you will have winter over there only when the sun is at Tropic of Capricorn, or the sun rays are falling on Tropic of Capricorn. All right, so this is what a brief explanation about some of the concepts associated with the geography. So we shall wind up our today's session. So if you have any more doubt, you can always discuss with me. I would be happy to resolve your doubts. Thank you very much, and we shall meet in the next class. Thank you.